Hi, uh, this is Matz, the creator of the Ruby. So that today I'm going to talk about the Beyond Ruby 3. So the Ruby 3 was released on the December 25th, 2020. So we have Ruby 3 finally released. So the last 4 or 5 years, I, I have been talking about the upcoming major release Ruby 3 for a long, long time. So that, but it's finally there. So that it is compatible and it's faster and it's better. So that wonderful Ruby 3 is here. So that let me explain about the new features and the new feature of Ruby 3. The first important point is compatibility. Almost all 2.x programs runs on Ruby 3.0, so that it's very highly compatible. So that you know, in the past we have some uh, the troubles in migrating newer version, but this time, so that almost all programs runs on Ruby 3.0 without any modifications because the compatibility matters. So we have learned the lessons when we released the Ruby 1.9. It's kind of a tragedy because that we have to fix some of the missed features or the mistakes in the design, language design we had uh, we had until Ruby 1.8. So we had to fix, but it th those fixes introduced some kind of the portability issues. So we had some incompatibility in 1.9, especially in encoding. So since Ruby 1.9, the Ruby fully supported Unicode, but to support Unicode, we have to change the we had to change the encoding support of the strings. So you have to modify or update your applications when you have to migrate from 1.8 to 1.9. So the people made different decisions. Some people stay using the old 1.8 for a long, long time. The other part of the community moved forward to 1.9 and the forthcoming 2.0 and 2.1 or such. We had some kind of the community split for more than 5 years. The, you know, some people stayed using 1.8, kept away from our new features or our improvement for a long, long time. Similar situations had happened in other languages too. For example, the Python 3 had some compatibility issues. And PHP 6 had a very, the brave change. But, you know, the many of the community did not want that kind of the big change and then with incompatibility. So the project itself was canceled. This very similar things happened in the ECMAScript 4. The ECMAScript 4 was canceled as well. So that, you know, we language designers are mere mortals. So that we did make mistake. So that, you know, there are several issues and features that I like even in the Ruby 3. But you know, I want I really really wanted to fix them, but those fix introduces those fixes would introduce the incompatibility, which is very, very bad. So that I mostly, most of them, I gave up to fix. We language designers really, really want to fix those mistakes, but you know, it's kind of the you know the self satisfaction, so that it's no use for the users. So that except for the little bit cleaner language, no, it's no use for most of them. So that I, you know, it was very tempting to fix those mistakes in the major releases like Ruby 2.0, Ruby 3.0. But we have learned when we released Ruby 1.9, the compatibility matters. So that, you know, even in the major releases, we do not, we would not make those, incompatible changes. So that, you know, we, as I said before, the major version upgrade is tempting to make that so that we can make incompatible changes. But no, we already had those many tragedies. Ruby 1.9, Python 3, PHP 6, Eclipse 4. So that Ruby 3 would not be like that. The programmers love new things, yes, but programmers hate pain forced by new things. So that I don't want punish them from the newer version of the language. So that compatibility matters. That's the lesson we've learned. The progress. We need to make progress. We are open source. We have to keep moving forward, but we have to make progress without breaking the past. So that we should keep compatibility. We try to keep full compatibility. So that we had many new features in Ruby 3.0, but basically we try to those new features. Try to make those new features done keeping compatibility. So that I admit, except for a few bugs. Some programs can rely on the buggy behavior in the past, so that we had to fix them. So that those very small amount of applications which relies on the buggy behavior need to be fixed. But except that, Ruby 3 will keep the compatibility. The second one, the performance. The as much as uh, performance, I mean, as much as compatibility, the performance matters. The, as I told you, we had the Ruby 1.9 tragedy and then the 5-year community split. But similar tragedy happened in Python, the Python 3 problem. But they had more than 10 years of the community split. So we had 5 years, they had the 10 plus years. So what's the difference? I believe this difference caused by the YAV, which is the new virtual machine introduced in the Ruby 1.9. So that new virtual machine was far faster than 1.8, the previous versions. So the performance matters. So that people, most of the people willing to pay the price of migrating to newer version if they can get the better performance. So the performance matters. That's why we have introduced the JIT compiler, just-in-time compiler, which dynamically generates native code. The code name of our JIT compiler is mjit since Ruby 2.9 to achieve the Ruby 3 by 3, which means the Ruby 3 will run 3 times faster than the previous Ruby 2.0. And in some benchmarks, we have achieved Ruby runs 3 times faster in some benchmarks, especially the Opticality. Opticality is the very CPU intensive benchmark task, which is which the JIT compiler works very effectively on that benchmark. But unfortunately, not in Rails application yet. The first version, the Ruby 2.6 JIT, Rails application runs 2 times slower using JIT compiler. But now Ruby 3.0, it's almost same performance with and without JIT. That's much better. But we expect faster Rails applications. So we are working on it. We are improving. So that with micro benchmarks, we are doing very, very, very good for the JIT compiler. But yeah, we are making more progress. The more VM optimization to come. So to improve performance, we are also working on the concurrency as well. 1993, when I first started developing Ruby, generally at that time, 1 CPU per machine per computer. But when you buy a new computer, your software run faster. Yeah, it was good time. But we have no free lunch any longer. Single core performance is saturated. But we are now under the multi-core age. We have a lot of cores in the computers. We have the dual core machines, the quad core machines, octa core machines, or even the more than 100 cores in the chip on the server machines. So that dual core, octa core, 64 core, or even 128 cores in Threadrippers. But so you have to use more cores to achieve the better performance in these days. So in that means the concurrency is a key. But unfortunately, Ruby VM has GEL, giant interpreter lock, because the thread safe runtime is very hard, especially for existing languages. But we have to improve our concurrency to use multi-cores. So by the existing due to the existing the global interpreter lock, we are safer. Our virtual machine would not crash when we are run in the threads. But we cannot use the multi cores fully. So we have to improve that. Our key ideas are introducing 2 new things in the Ruby 3. One is the async fiber. The second one is Ractor. Let me introduce the async fiber first. The async fiber is designed for I/O heavy tasks, like a web server or some kind of the I/O heavy programs. Like these days, some languages introduce the async and the await in their syntax. For example, JavaScript has async and await, the Python have async and await, and the C# has async and await. So those language, Node.js as well. So has those kind of the asynchronous task processing to introduce that IO multiplication. The Ruby 3, we do the async IO with fibers. So we use fibers. We are not going to add any new keywords like async and await in the language. Then the in the under the async fibers, the context switches on any IO operations which blocks, so that you 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 will know the control of threads can be the switched back and forth on the IO operations or the blocking operations. For to use the async fiber, so you need to specify the fiber scheduler. The, the important thing is the async fiber does not use multi-cores. We just multiplicate the I operations to to you know to utilize the core more effectively. You know, that by using traditional block operations, the the CPUs just wait for I/O, and by using threads, the you know the CPU does not block, but its context switch is heavier than fibers. So by using fibers, we are lightweight context switching. We have the lightweight constant context switching, and we have the multiplication of the I operation, the blocking operation. The faster context switching is very good. Like yeah, remember, for example, the Node.js itself is single-threaded, but it's fast because of the this kind of the asynchronous task processing by using the async promises and the async and await. So that similar things could happen in using the async fiber. Yeah, we will get the faster performance for the IO heavy tasks. For example, the Falcon, which is the application server for Ruby, yeah, using the fibers, uh, achieve the performance using these fibers. This is a very similar idea. Actually, the newer version of the Falcon and the Async Gem use the fiber scheduler, the Async fiber. And actually, the person in charge of the Async fiber is Samuel Williams, which is the author of the Falcon, the application server. So the async fiber does not use the multi-cores. So how can we use multi-core for CPU intensive tasks? For that purpose, we provide a Ractor, which stands for the Ruby actor. Ruby Ractor is basically isolated object space. The communication via the sort of channels. The no state sharing, or actually the limited sharing. So the objects which are immutable and recursively frozen for class or module uh, can be shared between Ractors. No other object uh, uh, not shareable. So that we don't have the GIL between Ractors. So that means that we can use the multi-cores. So that we can fully utilize the multi-core without the blocking block. This is the very stupid Ractor benchmark. We make the try benchmark function. Then the first one is the sequential calculation of the try function for 4 times. Then the second one is the create the 4 Ractors, then calculate the try function in parallel in 4 times. This is a very stupid and artificial benchmark, but uh, this under this benchmark, the parallel version runs 3.8 times faster than sequential version. That means that nearly theoretical scale of the performance boost. This is the actual ones, so that I don't claim that every function should be should act like that, create that kind of the performance boost, but at least it will show us the possibility of using multi-core. So the Ruby 3.0 should be better language, so that we are going to find more bugs that at the age of the static typing. You know, after these days, after 2010s, 2010, yeah, years since 2010, the static typed programming language are very, very popular. Became very, very popular. Go, Rust, Swift, and the many other language are very popular. So the dynamic programming language like Python, PHP, and JavaScript went to some some kind of the half static type programming language. PHP are the type declaration, the Python are the type hints. The TypeScript is the static type version of JavaScript. They are very popular. So that, yeah, it I feel like we feel like everyone goes static typing. So that, shall we? I don't think so. We don't want type declarations, but we do want more precise checks, and we do want to declare earlier, and we do want code completion based on types. But we introduced the static type checks for better programming experience. To achieve that, we added the Ruby signatures and the type prof. Ruby signature is the some kind of the TypeScript .d.ts counterpart, which is the type description language that you can describe the class and the methods with its type information. The Ruby3 ships with the RBS signatures for the core, and some gens ships with the core. If once we had enough type information from the signatures, so we will get the type checkers, static type checkers, or the better ID with better code completions, or type signature pop-ups, so that we would have we we will have a better programming experience through the editors and IDE. The type prof is another artifact we set with Ruby 3. The it does the naive type checks based on the signature, and it generates the signature for your applications, the prototype of the signature. I mean, for example, you have this kind of the Ruby program that we define class foo, the method foo, and the bar, and method foo takes argument A and then returns B, and bar is the similar. But look at the definition of the method bar. The it as the a plus string 2. But the later, the we create the foo objects. Uh, then so the foo object, foo method with the argument integer, and the bar method with the argument integer. The bar argument takes integer, so a is integer, but a integer plus strings is error, so that the type prof will run to error, type error. Then type profile generates the signature. The, this technique is used abstract interpretations. So they are using those abstract interpretation so that it will generate the class foo has method foo that takes integer and returns integers. The cross bar has, the method bar has uh, the type error so that it's not included in the generated signatures. So that we want even better Ruby, so that we add new syntax for example, the pattern matching and the number of block parameters. Pattern matching is like this. You match the pattern. So that pass the JSON, so that find the person named Alice whose children is Bob, and then print the age of some Bob. And then we also added the one-line pattern matching, like you know, it can be used as a assignment. It can be used as the multi-assignment. It can be used as the decomposition. It's sometimes very useful. And we added the numbered block parameters. The 1, 2, 3 maps as first argument times 2. Now, that's simple. Now, this these are compatible, very small changes, but it enhances you uh, the to write shorter and more clear programs. But now we have Ruby 3.0. So let me talk about the beyond Ruby 3. I'm very satisfied with the Ruby 3.0 and the direction we go, but I'm not satisfied with the status of the feature completion. So we need to improve our implementations. It should be faster, and we need to fix more bugs, and you know, and we need to add more new features. So that some new features may be buggy, and some uh, new features may be the feature incomplete. So we, especially Ractors, so that we need to improve that kind of things. The basically the direction is correct, but we need to see completions. But and also we are going to improve the supporting tools for Ruby programming. For example, the Solar Graph, the language server protocol server, which can be used as you know the IDE, the common IDE programs. We have Solve and the Steep as a static type checker, so that we can be improve those things by the supporting the Ruby signature or the more interaction with the people. The Robocop is the very useful linting tool, but I think the signature or the Ruby new features can improve the Robocop for better experience. The better tools enable better user experience. So that by using those tools, we will have the better Ruby programming experience. So that we need more tools to improve type checkers, formatters, language server protocol, the performance tuning, debugger, or whatever. So that by improving those tools, we will have the better productivity. So that I'm not going to add, static typing or we are not going to change the language that much, but adding those tools, improving those tools, so that will enhance your Ruby productivity. At the last but not least, I want faster Ruby. People trust micro benchmarks. I see many cases who uh, pe people decide languages based on micro benchmarks. I hate that. But the reputation is formed by micro benchmarks. So that, yeah, I admit it's it's kind of sad, but okay. Okay, we will improve the performance for micro benchmarks. So that we are going to add a better jet, or perhaps this is just idea yet, but perhaps we are going to add a multi-layer jet. The, we have the M jet, but we are going to add. We might uh, be going to add the lightweight jet in front of the M jet, which might be based on the meal or the Async. And yeah, Raptor performance should be improved too to have the even more performance improvement. And the last one is just my crazy idea, but a static barrier is one of them. So that in Ruby, the Ruby is very dynamic programming languages, but some dynamic aspect of the language will be prohibited beyond this barrier. So that upon after this barrier, the for example, the method definition is prohibited, so that the method cache will work more efficiently. JIT compiler can be more efficient, so that uh, we can have the more, say, performant and more optimized friendly Ruby without hindering the, the nature of the language. Anyway, uh, at least I promise we will keep moving forward. The Ruby, we will improve Ruby. We will keep moving forward to create a better world. I believe Ruby, and Ruby is very good language, excellent programming language. Yeah, that's why I created Ruby. But the whole purpose of the existing of Ruby is to create a better world. So that I I'm very honored. So many people use Ruby, and so many people use Ruby for to create great applications. Whether GitHub is based on Ruby, and Shopify is based on Ruby, and the Cookpad is based on Ruby. The, those applications, those services improve the world to for better. So that the, I'm very honored to the part of this great work to improve the world. And I invite you to join us to make the better world by using Ruby, by supporting Ruby, and by enjoying programming with Ruby. Thank you.